So continuing on, now we're going to divide and simplify the fourth root of 1024x to the 15th over the fourth root of 4x. So since our indexes are the same, we can combine like terms. So it's going to be the fourth root. 4 goes into 1024 256 times. X to the 15th over x is x to the 14th. So let's prime factor 256. That's going to be 2 times 128. 128 is 2 times 64. 64 is 2 times 32. 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. So how many 2's do we have here? 1, 2, 3, 4, 5, 6, 7, 8. So we can write this as the fourth root of 2 to the 8th power x to the 14th. So let's look at our index. 4 goes into 8 2 times, so 2 squared comes out. 4 goes into 14 3 times, so x cubed comes out. And what's left? X squared. So 2 squared is 4, so it's going to be 4x cubed times the fourth root of x squared. So the answer would be A if you have those in your notes. Okay, so it's easy. Just prime factor and get everything into exponents. All right, to rationalize the denominator of an expression, rewrite it so there are no radicals in any denominator and no denominators in any radical. Rationalizing the denominator of a numerical expression makes it easier to calculate its decimal approximation. For example, 1 over the square root of 2 we can rewrite as square root of 2 over 2. And it's easier to divide by 2 than it is by the square root of 2. Okay, so let's rationalize the denominators. So rationalize the denominators. So I have the square root of 2 over the square root of 3. Well, now all I have to do is make the denominator a perfect square. So if I multiply the denominator by the square root of 3, what would I multiply the top by? Square root of 3. So I'm going to get the square root of 6 over the square root of 9. But square root of 3 times square root of 3 is 3. So my answer is the square root of 6 over 3. Okay. Let's look at B. I have the square root of x cubed over the square root of 5xy. And again, remember, since they're both to the same root, we could simplify this to the square root. We can cancel the x's of x squared over the square root of 5y. And what's the square root of x squared? It's just x. So it's really x over the square root of 5y. So now we've simplified it. Simplify it first. Simplify it first. Now, what do I have to multiply the bottom by to get rid of the radical sign? Well, I have to multiply it by the square root of 5y. So I'm going to get x times the square root of 5y over 5y. Nothing else will cancel, so we're done. Again, you don't have to do the simplification first. It just saves you so much work in the beginning. All right. So now I've got the cube root of 2 over the cube root of 3x. So how do I get rid of that? Well, the cube root of 2 over the cube root of 3x. Well, I need to have 3 of those. So I need to make it a perfect cube. So I need to add cube root of 3x times the cube root of 3x. If I do that to the bottom, I have to do it to the top. So cube root of 3x, cube root of 3x. Okay, so what's my denominator become? Well, my denominator is just going to become 3x. So what's my top going to become? Well, since my indexes are all the same, I can just multiply everything. So 2 times 3 times 3 is 18. And x times x is x squared. So it's going to be the cube root of 18x squared. And I cannot factor 18 down any further. Okay? So let's get some examples of this and get rolling. Rationalize the denominator of the square root of 7/5. Okay? Again, I'm going to break it down as the square root of 7 over the square root of 5. I need to multiply the bottom by the square root of 5 and the top by the square root of 5. So I'm going to get the square root of 35 over 5. I can't simplify it, so we're good. Alright, now we're going to do the square root of 2x cubed over the square root of 10xy. Remember, since the indexes are the same, we can simplify. So get a different color pen so we can see this. So I can cancel the 2 and the 5, make it a 1. I can cancel that x and make it a squared. So now I have the square root of x squared over the square root of 5y. Okay, we just did this one, didn't we? So it's just going to be x over the square root of 5y. Now what do I need to do? Multiply the top and the bottom by the denominator in this case to get rid of it. So I'm going to get x square root of 5y over 5y. 5c. Cube root of 4 over the cube root of 6x. Well, let's simplify. So I can make it let's simplify. Since the index is the same, we can go ahead and simplify. I can make this 2 and a 3. So on top I have the cube root of 2 over the cube root of 3x. Now I need to multiply the bottom. Since it's a cube root, I need to multiply it by the cube root of 3 twice. And if I do that twice on the bottom, I've got to do it twice on top. So that's going to be the cube root of 18x squared, which doesn't simplify, over 3x. And we did that one earlier, I think. Okay. So real world connection. Einstein's famous formula E equals mc squared relates to energy, mass, and the speed of light. The expression C in terms of E and M, and rationalize the denominator. So E equals mc squared. So C squared equals E over M. So C equals the square root of E over M. So again, this is where I'm going to change it. Let's look at, I'm going to have the square root of E over the square root of M. So now I'm going to multiply the top and the bottom by the square root of M. So I'm going to get the square root of EM over M. Easy enough. The formula AD over T squared relates to the acceleration of a moving object to the distance D it is moved in time T. Solve for the formula for T and then rationalize the denominator. Okay, so I got A equals D over T squared. Okay, going to cross multiply, so I'm going to get T squared equals D over A. All I did was I multiplied each side by T squared and divided each side by A. Now I'm going to square root this thing. So T equals the square root of D over the square root of A. So how do I get rid of the radical sign in the denominator? Multiply the top and the bottom by the square root of A. So time equals the square root of D times A all over the A. Easy enough? Okay. Well, that's the lesson for the day. Good luck.